Hello, everyone, and welcome to today's AASHTO NTPEP educational webinar for the High Friction and Thin Overlays Evaluation Program. My name is Catherine Molesky, and I'm the Program Director for AASHTO's National Transportation Product Evaluation Program. And along with me today, I have the leadership of this technical committee for NTPEP, Kelly Morris with Illinois, as well as Danny Lane with Tennessee DOT. This presentation is being recorded, and it will be available on the NTPEP YouTube channel after this webinar concludes. If you guys have questions during today's webinar, please enter them into the Zoom chat box, and we will either review these questions at the end and provide answers, or we will provide a follow-up response via email or a phone call if time does not allow for us to get through those questions. For those who may not be familiar with AASHTO's third largest technical service program, NTPEP stands for the National Transportation Product Evaluation Program. The purpose of this program is to combine both the professional and physical resources of each of the state departments of transportation to evaluate materials, products, and devices used on both roadway and bridge construction. The primary goal of this program is to provide cost-effective evaluations for the DOTs by eliminating duplication of the testing and the auditing services by the states, and it also removes the duplication of the manufacturers to provide these products and the data to the state DOTs. Some of the benefits of this program, NTPEP pools resources to save the states and manufacturers both money and time. The data from the product evaluations and the audits are available on our NTPEP DataMine website. The NTPEP members contribute to the work plans that are utilized to carry out these product evaluations and audit programs. The NTPEP technical committees provide a platform for both the states and manufacturers to share their expertise and voice any concerns they may have. By this unique partnership, we are able to sustain a high level of quality for these products that are being evaluated within this program. What is the NTPEP DataMine website? It's commonly referred to as NTPEP DataMine 3.0. It is the online repository of all of the data and all of the audit documentation that gets put out as a result of the evaluations and audits taking place. This database provides the tools for you can perform queries that will assist you in analyzing and reporting on current and past NTPEP evaluation. It also allows the test facilities and the auditors to enter real-time data. So as the testing gets completed, as the audits get completed, this information is available to all of those registered users in DataMine. If you do not have a DataMine account, I highly encourage you to check out the NTPEP DataMine website, and you can click the login button. And if you do not have a login, then you can click to register and you can get an account set up so that you are able to access all of the data that we talk about during today's webinar, but also for all of the other 26 different evaluation and audit programs. In addition to performing queries on this platform, you are able to look at different safety documentation, as well as any additional pictures and videos that are taken as part of the field evaluations within NTPEP. Where to find NTPEP? So this is a screenshot of the NTPEP website, and you could also access mine from this site. So definitely familiarize yourself with this site if you are interested in either utilizing NTPEP for the first time or continuing to use NTPEP. This is a great tool to go out to see. The map in the middle shows you what states are utilizing which programs. So if you are interested in knowing either what your state's doing or your neighboring states are doing, and if any of that information may be a little bit inaccurate and you are now utilizing a program that your state may have not been using previously, bring that to my attention. Our contact information is out on this website. So now I'm going to turn it over to Kelly Morris, who is going to talk about what happens within the laboratory as far as the high friction thin overlays evaluation program.
Good afternoon. Thank you, Catherine. I am Kelly Morris with the Illinois DOT. I am the Vice Chair for the High Friction and Thin Overlay Technical Committee. I will detail the work plan for the High Friction Thin Overlay program, specifically, as Catherine said, the laboratory testing. I will then hand off to Danny Lane, our committee chair, to discuss the field evaluations and reporting. This technical program evaluates the individual materials, polymeric resins, and aggregates used to construct the overlays, as well as the performance of the field constructed overlays. The overlays consist of a plural component binder application with an aggregate broadcast onto the surface and embedded into the binder. What is a high friction thin overlay? It's a cost-effective overlay system that can preserve and improve pavements and bridges. They can provide an improved wearing service and provide protection from water and chloride intrusion. They are lightweight, easy to construct, and durable. Now that we know a little bit about what high friction thin overlays are, we can explore what the NTPEP program provides our users. The high friction thin overlay technical program contains 4 basic components. The first is the e-application and testing fee schedule that manufacturers consult and apply in order to participate in the program. Next is the work plan that provides the structure of the program and outlines exactly what the testing and evaluation program entails. Next is the user guide, which serves as an implementation tool for agencies to utilize to determine how they can best use the program. Finally, Data Mine is the repository for all the data and the reports generated by the High Friction Thin Overlay program. The fee schedule for all of the technical and audit programs are found on the NTPEP website. The general description gives an overview of what will be included and the product evaluation or audit fee. This program is comprehensive in that it provides for both lab testing of the individual components of the overlay system, as well as the field evaluation of the constructed overlays onto multiple substrates, including asphalt, concrete, and a concrete bridge deck. The work plan is a summary of the specifications, processes, sampling, and inspection procedures that will be followed during the evaluation of the high friction thin overlays. This work plan will be followed for each material submitted to the technical committee. The work plan standardizes the evaluation and allows for consistency, reproducibility, and transparency. When states utilize the NTPEP programs, it streamlines and improves the overall quality of the high friction thin overlays constructed in all of our states. The laboratory evaluations are included, as well as the 36-month field evaluation. Sampling is also outlined in the work plan. The integrity of these samples is critical to the program's success. Representative samples of the polymeric binder resins, both Part A and Part B, are sampled separately from the material that arrives at the field test site locations. A representative sample of the aggregate is also collected. These samples are labeled and secured by NTPEP staff and delivered to the High Friction Thin Overlay Test Program contracted laboratory for the testing. Samples must be submitted to the designated facility in sufficient quantity to conduct all of the testing, as instructed by the NTPEP representative, along with information showing the manufacturer's name and description of the product, the manufacturer test results, a sample of the binder and surface aggregate and/or aggregate fill in sufficient quantity to conduct the specified product test, and the materials will be limited to 2 per manufacturer per year. A generic material composition description and SDS must accompany the submittal for classification purposes. There are several different binder systems used in this program, and we want to be clear on which system we are testing. This information will be kept in confidence by NTPEP unless directed otherwise by the manufacturer. Future Labs, LLC is the High Friction Thin Overlay contracted laboratory. They have done an excellent job with this program, and were generous enough to provide the photos that I will use to describe the lab testing aspects to follow in these slides. They perform both the polymeric resin binder testing as well as the aggregate testing. The binders are tested as individual components as well as mixed. The properties tested on the binders include viscosity, gel time, tensile strength, tensile elongation, tensile modulus, absorption, surety hardness, compressive strength, and an infrared spectrum is collected. The properties of the aggregate tested are gradation, absorption, micro-Duval, and the XRF spectrum is also collected on the aggregates. The testing performed is done in accordance with standard methods of both ASTM and/or AASHTO. Details regarding the mixing and curing are provided by the manufacturer. I'm now going to dive into the details of each method in the next few slides. After the components of the binder are mixed in accordance with the manufacturer's recommendation, viscosity is performed in accordance with ASTM C881. The spindle and speed selection are based on ASTM D2556, the year number 11 because of the spindle selection chart in the appendices. The gel time is evaluated on mixed binder material in accordance with ASTM C881. The components are mixed together and placed in a cup, and the gel time is then tested. Tensile and elongation properties of the mixed and cured polymeric binders are tested in accordance with ASTM C881. Data mine will include values for tensile strength, tensile elongation, and tensile modulus. This is a depiction of the graphs that are collected during that testing. Absorption will be evaluated on the mixed and cured binders in accordance with ASTM C881. These photographs depict the testing as done in the future laboratories. The Shore D hardness testing will be done in accordance with ASTM D2240. These are a couple pictures showing the testing in progress. Compressive strength of the mixed and cured binder is also done in accordance with ASTM C881. The specimens are cured for 7 days. This is an example of the graph of the compressive strength analysis. An infrared spectrum is collected on all the binders. The spectrum is collected in a standardized manner that allows agencies the opportunity to use those spectra in both a physical paper format or electronic format to evaluate the materials that are supplied to their state with those submitted to NTPEP. This is a way in which states can perform a quality assurance test and utilize the high friction thin overlay program to verify that data. The aggregate portion of the high friction thin overlay systems are evaluated by the contracted laboratory as well. Future Labs also does the aggregate testing. Aggregate is tested for gradation, absorption, microdevol, and X-ray spectrum. As mentioned previously, representative samples are collected from the field evaluation test site. Those samples are processed by the lab for each of the tests performed. Most states have their own criteria for the aggregate, and the high friction thin overlay aggregate evaluation data may be used to verify compliance with your own state specifications. Microdevol testing is performed in accordance with ASTM D7428 with modifications. Those modifications can be found in Appendix A. X-ray fluorescence, XRF, are analyzed to determine the elemental analysis of the aggregate. Again, this data may be compared to state specifications for compliance with chemical requirements within your specifications. It is now my pleasure to hand off the presentation to Danny Lane with Tennessee DOT. He is the esteemed chair of the High Friction Thin Overlay Committee, and he's going to discuss the field evaluations, data mined, and the new reports being prepared for the high friction thin overlay products evaluated. Danny?
Thank you, Kelly. Can everyone see that? Am I showing what it's supposed to be showing?
Absolutely, yep.
Yes, sir.
Okay, great. Well, thanks. And we have a nice crowd here today, 70-something people. It looks really good. But let me get started. And Kelly went over what we do in the laboratory and what Future Labs has done for us. And later on, she'll share some other things that they've done a really good job, and we're glad to have them aboard. Well, my name is Danny Lane. As you well know, I work for Tennessee DOT. I did a lot of these demos and stuff like this long before we had the HFTO field evaluations. But so I got to be part of that in 2012, 13, and 14 in Kentucky, 2016 and 17 in Tennessee, and now in Missouri. What I'm going to do is share with you today is what we look at in the field when these things go in. Now, we've already pulled all the samples from the staging area. We got all them secured, piloted up, and ready to go to future labs. And now each of these suppliers hired contractors or themselves to put these products in. And of course, we all know that it's a 200-foot section on concrete pavement, asphalt pavement, and a bridge deck. And we all know that bridge decks gets double layer. But what we do with the HFTO field testing is all the concrete, whether it's a bridge deck or concrete pavement, is shot blasted to a certain degree, CSP 5 and CSP 7 in between there, with the International Concrete Guide 3102. Site must be free of all dust, loose material prior to applications. The Missouri DOT and NTPEP got a company out there to shot blast these areas to have them ready to go when we do apply to the concrete. The asphalt, of course, is all just air washed like we do in every day in a regular contract. Our host was Missouri DOT, and Todd Bennett and his folks there stepped up this year, and they picked a heck of a place. Myself and Richard Weber from our department went out there and visited and looked at these site locations and really got excited. I think it's going to really be a really good test for these products. The 2 days of installation was September 28th and 29th. As you know, some of these test decks we did in June and July, and buddy, it is hot. But it was still hot even in September, but the starting temperatures were 60 and ending in the 90s. So our deck temperatures did get over 100 in some areas. And each site has a NTPEP representative. What happened is originally in Kentucky, I came up with some field notes, but I was stuck on the bridge for 3 days and that weekend. So everybody that came to the bridge, I had to look at their products, go down and take notes and stuff like that. We changed that in Tennessee. We put an engineer or a technician with each supplier, and they followed that supplier around to every deck so they could take notes and record start and finish times, cure times, and things like that. So we document all that, and I'll show you that later too. Manufacturers participating was Cornerstone, Epiplex, Mineral Research. Now, Minerals Research is a aggregate that they use. They did use a binder from EChem to put this in, so that's going to be recorded too. But SharpsGuard is a aggregate that we're looking to prove. And as you know, if you've looked in other test decks in Tennessee, we had 5 different aggregates, and I will let you know that 2 of those come out ahead, and TDOT is using them now. So we're excited about that. We like the fact that not only binder systems, but aggregates get to participate in this too. A&A Safety was the contractor for P3 infrastructure that had 2 products, Impervious ME and Altera, and then Polytough Systems International ETUF. So we had a good manufacturers participating in this program. We're not as quite as we had in Tennessee, but still a large crowd. We use bridge deck test locations, and it's really funny about this. Kelly come up with this guide, these test deck locations on a Google map. You can actually, from our report, be able to go to GPS, and you know Missouri is a flyover state, so they get Google Earth brand new every year. But we will have pictures every year and everything, but you still use the GPS to go look at these, which I have done several years after, even in Kentucky. So remember that. We'll have all those locations listed. And there's her map showing the proximity of the test decks. There was about a 35, 40-minute ride between concrete and asphalt, and all the bridges were in between. Representatives on site was Catherine, of course, Todd Bennett, and Seth Bollinger from Missouri. They did a heck of a job. Seth pretty much did the deck prep and all the traffic control, and did a heck of a job for us, because you know we do have people out here on this test deck and they need to be protected, and he did a great job. Leonard Vader was a technician, a chemist with Todd. He was one of the representatives. Madeline Whalen, myself, Richard Weber, and Kelly Morse we all had a supplier that we stuck with both days, and so we followed them. We knew every move they made, and we could document everything that goes on. Also, some more friends, Justin Morris and Khalid from Louisiana, showed up and gave us a hand. They got to see some firsthand experience of how this test deck goes down and what happens in that 200-foot section that needs to be done and done perfectly. And you'll be surprised when you look at these reports that they all kind of done a little differently. Not everybody does it with a mechanical mixer. Some are the same, some are not, but you'll get to see what goes on, but they all come out pretty good. I came up with this sheet years ago to use in Kentucky. It's a note sheet that you know where you're at when you start to take pictures. You take a picture of this note sheet. So I'm going to be on bridge 1, A0030, and all my notes, what happens on that bridge, it goes in this because we'll have to transfer them later. It's hard to do this with a pad out in the field, and we all know if anybody's done anything in inspection, it is kind of hard to do to take notes. But we come up with this to get everything in order. So when that person is following that supplier around, they get to take the notes on everything they do for that particular test day. What we do is we photograph the worksheet, the designated location. So every photograph that comes after that is for that test deck. And that helps our inspectors, our reps that are going with these suppliers to keep up with everything they got and put it in later when we put it into a file. We verify the structure number and location. We document the time and start of the first and second application. Of course, the second application is only for bridge. We do try to do the deck temperatures and air temperatures for both, give you an idea of when and how this stuff was put in. We try to do the cure times. We do know that these products, these binders, cure within an hour or two after placement. And some of the times the contractor would leave, go to another test deck, come back and later sweep off. That doesn't mean when he came back and swept off 3 or 4 hours later, it took that long to cure. Most of these are traffic turned on them within 2 hours and sometimes sooner. I don't recommend it, but some of them are faster than that. We do the part and the mixing details, the part A and part B and lot numbers and all that. And that's for our future lab people. So we have all of our samples. We know where they came from. The photographs taken demonstrate the process and steps taken to install the HFTO. And then in the report, we show the final 20 pictures for the initial application and every year after that. In the 2021 HFTO test deck, the photographs, the concrete desk, of course, was shot blasted. Everything was air blasted. And some of the suppliers did this on their own again, just to get loose impediments or anything off the deck that they felt like they needed to. The deck was 200 foot long, 12 foot wide, edge line to skip line. And as you'll notice, you'll see some of these, all of them use a duct tape or something to protect the line. We do this practice even in Tennessee. But when we're doing a bridge deck, we do go wall to wall because we want to protect the complete deck of that bridge. And again, we use it extensively in the state of Tennessee. The truck and materials, most of them come with assisted mechanical mixers. In other words, they have a part A, part B tank along with the aggregate. And what they do is they come through a static mixer and it mixes it right on there. We found out even in the materials testing laboratory that this is the best way to mix the A and B, even in the laboratory. So we found out a lot of good things with future labs working with those guys this year. And they really like the idea of that. And that is exactly how it's done in the field. The application, we're going to show you all the applications for these and how they do in a picture sequence for each test deck. And you'll see how the process is done. If you'll notice these 3 pictures here, the mechanical mixer is dropping the binder, the guy is squeegeing it, and the guy with the aggregate is coming in behind it and placing the aggregate on top of the binder. Post-application deck preparation, of course, they pull the tape up before it sticks too bad, and you do not want to let that happen. After the tape's removed, they blow the aggregate on top, then come through with a sweeper or a broom of some type to remove the excess aggregate. On bridge decks, the second application, they usually do an air wash. Then they go right back on top. They put the tape back out and they start their second application. As a rule of thumb, everyone needs to know that it takes almost double the binder to do a second application for a bridge deck because of the surface area of that, but it just nearly doubles the binder quantity for a second application. In the state of Tennessee, we'll let you know anything on concrete gets double layer from us because we do not want to have to go back out there on that concrete. We understand that asphalt has a lifespan and will be ground up later on and used as wrap, and the binder or the material used on these on asphalt does not do anything to your wrap. Repeat, it does not do anything to your wrap. You would never even know it. It still acts as maybe a sand or a small aggregate. And then we do the post second application. The tape is removed again, and then we give you final pictures. I'm going to share a report with you now. Let me do this and pull this up. Okay, give me a thumbs up. Can everybody see the report I have in front of me now?
Yes.
Okay, great. I did remove the names. All of the reports have been completed. They will be assigned to their suppliers and manufacturers for their review. So I just took the names off of this. But it was really funny when we got through with all of these, all of our representatives putting in their notes and putting them in a Dropbox. Kelly sent her report in this form right here, and it automatically clicked with me. From the old data mine, you used to put in products, for the binder, all the data for the binder, and then the aggregate, and then I would show a different PDF for the pictures and the install. Well, it clicked with me. Let's take everything, put it on Excel spreadsheets and Word, and then drop it into a PDF. So when the states go to look at a product, HFTO 2021-01, whatever, they get to see everything that goes with that one product in one document. So that's what we decided to do. I had help from Richard Weber with the spreadsheets and Kelly Morris, and then I put together this report. So let's kind of go through it. In the table of contents report in the Word document, you will be able to click and go to anywhere you want to go in this report, but it's really just a follow through and the place holder for areas inside the report. We give a summary of the program and what it's all about, what you just learned earlier in this webinar. We have the NTPEP designated labs, is Tennessee Department of Transportation, Missouri, our friends from MoDOT, and Future Labs from down there in Mississippi. Very good lab. Test deck locations, again, even on these sheets we'll show you in a minute, I have the GPS coordinates, but we show you exactly where all this was and the friction values that go with them. Tennessee DOT performed the wet wheel 40-mile-an-hour skid program. Missouri does not even have that program. So we crossed that state line and go over there and help our friends out. And we really enjoyed it. Our skid guy did a heck of a job with this. So we got averages on all the asphalt and the concrete deck, and each bridge deck got a controlled friction value before we put anything on these substrates. Like I said again, I took out the manufacturer's name and the product, but I do go through it, and it does have a product description, a binder description, the grade, the class, and things like that. So most of you people in the laboratory and stuff, if you like epoxies you work with, you know the kind you want, all of that stuff's in there. We describe the surface aggregate description. In this case, it was a bauxite, granite, or basalt. In this case, it was a calcined bauxite. And then we go to the laboratory evaluations, our friends from Future Labs. I took the names out just because we're holding this information to be reviewed by the manufacturers. All this will be released and you'll see everything. But you'll notice all of the laboratory evaluations coming through in one document. Again, sieve analysis on all the aggregate. We actually do two sieve analysis, micro Duval, moisture content, and aluminum oxide content. which is really big for our calcine bauxite. A lot of these have requirements on there inside some of these other standards, and you may have some in your own state standards. So now we get to the field evaluation. We describe the installations, a 200-foot long, 12-foot wide, how it was prepped, and who we worked with to do this. And then we come up to the first section of the asphalt test deck. First things first, Richard Weber of our group created a spreadsheet. So we put all our notes from that paper that we used out in the field. Each engineer or chemist or technician that was with each manufacturer put all of his notes into here, his or her notes, and we got all the data that we did out there in the field, so you can see all this cure time, total time it took, and most of the time that 200 foot didn't take but like 30 minutes to put in. So and that was mechanically assisted and or hand applied and hand mixed in some cases. We mark the sections, which every one of them are with a number. We get all that straightened out. Then we talk about the installation, how the crew pulls up and using the A and B parts, what they used, and the lot numbers and that type of thing. All this came from that note that was made in the field. Then we actually start showing the equipment of how the truck is mounted, the A and B, and things like that. Then we go start with the asphalt deck prep, and we do this for concrete and bridge deck. So these guys right here are taping off the areas they want. They're saving that line. They're going to put this down. He's going through with an air wash, and as you see, traffic's going by us, and there's several lines of this asphalt test decks. The asphalt and concrete was back to back, back to back, back to back, with about 100 foot in between, and so everything was pretty much on an even level. We was really proud of the test deck locations that Missouri picked, and especially after this winter we had this year, it's going to turn out really well. We start talking about the install too, and you see how things work. You kind of get to walk through. If you'll notice, he's dropping his binder out right here. It's coming through the static mixer. He's starting his squeegee process, and the guy comes along behind him with the aggregate, blowing the aggregate on. This was a good operation. These guys really had it together on this, which most of them do, and they've done this before. As you know, they got one guy squeegeeing and one guy blowing the aggregate and then just checking the equipment. And when they get to the end, they stop, and then they start pulling tape and doing things. If you'll notice how it keeps coming together, they blow the excess aggregate on, and then they come by and they sweep or vacuum and to remove the excess aggregate. So what we do is 1 month later, we came out, actually it's a little less than a month later, we do the initial layout pictures and the initial friction values for each one. What I try to do is get an overall look in the first picture with the total 200 foot, and then I go about every 3 to 4 steps, I take a picture. And if you'll notice, anytime you look, you can always zoom in and zoom out. We do have videos that are going to go with these. We're having a little harder process to do the videos, but we will have them out. As you'll notice, there are about 20 pictures that goes through here. Now, this is the initial. This is after it's been put in and the everything's finished. The contractor is gone. So now we're looking for the 3-year evaluation in the field and see how this thing performs. I do take a lot of pictures, but it does let you go about every 10 to 12 foot to see what exactly is in that test deck on top. These guys look really good. Not all of them look this good, but that doesn't mean they're not working. That doesn't mean they're not getting friction and stuff. It's just sometimes some products are put in differently than others. So we take a look at each one of these. And so they'll be able to do this. Everything for those 3 test decks for this product, including the skid, is in one PDF. And I'm really excited about that. You could actually take the 2 PDFs and put them side by side to compare products. As you'll notice, this asphalt control was a 47.5 with our initial. And this product right here took it to an 81.1. Again, we do that for everyone. Now, the next year will be a 1-year evaluation. They'll get the same 1-year evaluation layouts and the same 1-year friction values. We'll do that for year 2 and 3. It'll all be in one PDF. Again, we dropped over here and we go straight down to concrete and stuff like that. So that we do the same thing for each deck. Now, let me stop sharing and go back to Kelly, I believe, right?
That's correct.
Okay. Thank you, Kelly. And thanks, guys, for listening.
Thank you, Danny. Those reports are going to be excellent. What a great tool for us to use to identify the performance of these different products. So thank you for all the work that you and your staff have done to put those together. Next, I'm going to go into the high friction thin overlay user guide. These are excellent tools that NTPEP provides. It's an assistance to the implementation of the various NTPEP programs. Some people don't know where to start with some of these evaluation programs or audit programs. These kind of give a best practice. A lot of states provide some input on how they use them specifically in their states. I give you some contact information, how people populate QPLs, how they may use the data to verify compliance, to do some initial qualification before they may do their own testing in their own state. The high friction thin overlay user guide can be found under the documents tab. If you go to the technical committees tab and then click on the user guide under documents, that hot link there will take you to the user guide. Once you follow that link, you'll be directed to the high friction thin overlay user guide document. The high friction thin overlay user guide contains an introduction to the high friction thin overlay program, just a basic overview, kind of similar to what we've talked about today. It'll talk about some general cured binder properties that you should look for, the different binder types, some key aspects of the technical program. It'll give you an FTIR correlation procedure. I mentioned earlier in the lab testing that they run an ATR FTIR, how a state can then use that information that's provided as part of the program to verify compliance of the material in their states. And then it gives references from AASHTO for some AASHTO specifications for material performance properties that states could use. The user guide, as well as contacting anybody in the technical committee, can help states develop and or improve upon their own high friction thin overlay programs. I've personally learned many excellent strategies from my fellow NTPEP colleagues, and that helps me improve the materials and processes here in Illinois. So as I mentioned, the NTPEP high friction thin overlay program is constantly evolving and improving, and we as the technical committee understand that we will need to adapt and change in order to keep relevant and provide the best quality data and information to our state users. In that effort, we will be discussing the recent AASHTO Comp 4C harmonization efforts on the MP35, that was for the thin overlays, and the MP41 standard for the high friction surface treatments. And the goal is to implement some of those potentially into our work plan. Specifically, the changes that were made that were helpful are some of the sample preparation techniques and some of the testing details that would help improve the consistency and reproducibility of our current testing procedures. We'll also be looking for ways in the future to improve upon our sampling and field inspections of the products submitted to the high friction thin overlay program. Again, Danny and I welcome any best practices or some innovative ideas or any things that you guys are thinking that might help improve our program. Please reach out to Danny or myself at any time. We welcome the input. With that, I'm going to open it back up. Danny and I can take some questions. I don't know if there were any questions dropped in the chat or if anybody has anything they'd like to ask Danny or myself.
Kelly and Danny, Montana DOT had a question, and Oak asks if you can speak to the aggregate moisture at all. They are spinning their wheels on how to specify, test, and accept the aggregates, specifically moisture content. Does the evaluation program do any aggregate moisture testing?
I believe in that report, we do not do the moisture content, but there is a moisture content requirement, Oak. And I believe it.
Danny, can you hear me?
Yes.
Yeah, I saw in your in the report there it talked about T255.
I mean, yes.
So it looked like you were doing the testing, but in the current data mine, I didn't see that. Well, it's been a while since I looked. So, but it sounds like you're going to address it moving forward. So that was my question. Is if the evaluation is going to look at the aggregate and do a moisture evaluation, because if that's the case moving forward, or if that's how the work plan is going to be updated, then I think that will help us out.
I just went over that, Oak, and it is 255 is in there. And I was trying to quote what we say. I think it's less than 2%. We say in our spec.
Yeah, it's
0.2%.
Yeah.
Yeah. And are you having trouble with that?
Well, yeah, that's the thing is, we get there's a supplier up here in the Pacific Northwest I think people are aware of, and we get most of our aggregate from them. And, we've been sampling the aggregate when it arrives on the project, and sometimes it's less than 0.2%, which is our spec like everybody else's spec, and sometimes it's not. Sometimes it's as much as twice as much as that, which is still only 0.5% moisture. And so part of why I'm asking this question is it that important for the aggregate to be that dry? I'm getting way off topic here right now, but the specifications that are out there are 0.2%. And if we're trying to make sure that it's that dry, we're looking for help out. So if the program is evaluating it, showing that the aggregate can show up on a project in that dry state, then that gives us justification to say, hey, look, this showed up for the evaluation dry. It better show up on our projects dry.
Right. And quite frankly, it is important. That number came from Everyday Counts when this started, so several years back. Now, whether it has to be that dry or not, but it does need to be dry. We've had a problem in the state of Tennessee with epoxies and water, and they do not mix. They will not set up properly, and so you do not want to be throwing. We actually state in our special provisions that you have to keep the aggregate dry, and if you can't, it needs to be covered somewhere in a shelter. But of course, we do lump contracts if we do HFST, where a contractor can do several jobs, and he gets a staging area. He rents a place where he can keep his aggregate dry. So, but yes, and that being that dry, that's pretty dry. And I'd say if you're down around that, or even below that 2%, even at 2%, not 0.2, you're doing pretty good. But it does need to be relatively dry.
Well, we'll just look and see what how the evaluations work out.
Okay. Now, I think, Catherine, there's Jim Swisher has how is friction tested? And friction is tested, Jim, with a 40-mile-an-hour wet wheel skid that we do every day in our state. Again, Missouri does not do skid friction data, and there's reasons for that. So we're not going into, but Tennessee does. So we come over there. We don't do it using a BPN number. I've actually tried BPNs in the lab, and it's just a BPN and a wet wheel skid is not. There is no correlation there. You can come up with one maybe for your own aggregates in your own state when you do enough of the testing, but the skid is a wet wheel, 40-mile-an-hour wet wheel skid test.
Okay, thanks.
Danny and
There's also
Kelly.
a question about how much time required to evaluate a product. The field evaluations is a 36-month evaluation. We do it at 12 months, 24 months, and 36 months, as Danny mentioned. So typically it takes a little time to get data put into the reports and then reviewed by the manufacturers before release. But typically the 3-year mark is typically start to finish for these products. Danny, would that be true?
That is exactly true. And I'm going to tell you, Kelly, again, me going all the way back before we even did this in Kentucky, I had products that was in Kentucky and on Tennessee's test deck that I had already proven in my state, but I still made them go through the program. And here's what I did after that 1 year. If they still provided, that's Tennessee DOT only, because we had already had experience. But when a new aggregate shows up, I make them go through the complete 3 years, because I want to see that 3-year data on that skid and how it performs with that binder. And guess what? You know, some start out really well in the state of Tennessee. In 2016, we had 5 different aggregates. Well, one of them was a so-called calcined bauxite that did not perform at all. It looked great the first year. The second year went almost half into, and then all the way down in the 30s. Well, heck, we're back to where we started. So and it's a new aggregate that I want to choose. And we did this from the last one was, I'll tell you, the Washington Rock. And it's on this test deck, on one of the bridge decks. And it lasted just as good as the Flint, and did just as good right along with it. And so we actually approved that in our state for the bridge decks. So now we have Flint, calcined bauxite, Washington State granite for our thin overlays, which we do every month in the state of Tennessee. And we do double layers. Our structures division and our bridge repair guys put this in contracts all the time. And we're just about, y'all have heard me say this before, I personally think a brand new bridge being built, and we go ahead and get the curing done, the 28 days, get that curing compound off there. Let's go ahead and put a double layer on it. And buddy, we can retire and not have to worry about that. Of course, and we've just about got our structures, and structures is convinced that would be fine to do. And you get it on the front end of the cost of the bridge. And we all know the overlay is just a fraction of what that bridge costs. So why not do something up front like that? We like that practice. We're getting ready to start that in the state of Tennessee.
Hey, Danny, there's a question out there about skid testing, if it could be done at various speeds to establish a speed gradient line for the manufacturer's products. Primarily because not all locations in the states can be tested at 40 miles per hour.
And that's exactly right. And we even have trouble with that, Robin Davis, in our own state, that we're stuck with that 40 mile an hour. What we did with Virginia Tech and Kentucky is tried it at 20, 40, and 60, and it was a little bit all over the place. I kind of like to see some guidance from our friends at FHWA with the scrim and all that. They've actually come out to our test decks and did all of our 37 sections that we had in the state of Tennessee in 2016 and 2017. But some of that has been done, Robin, but it hasn't been conclusive. And we do have trouble with that 40 mile an hour on some HFST done on lower volume roads, but we try to get it done.
All right, thank you.
Is there any other questions? You guys do think of anything once the webinar is over, you're welcome to contact Danny or myself, and we can try to provide some answers or get back to the technical committee and get some more information for you or discuss at our upcoming meeting.
Thank you, Kelly. Also, remember, mark your calendars if you haven't registered. Guys, you've got to come to Nashville. If there's any NTPEP conference you need to go to, it should be this one. And but we got a lot of stuff planned for you. Even in the HFTO, Kelly, now we can show anything y'all want. If y'all want to see something, request it. We can actually show another report and how we did things, and even ask us how we do stuff in our own state. Even though Illinois and Tennessee has been on the same page with HFTO for years, we do install them a little differently Illinois is a fully automated, and which I totally respect. And we do a little bit of both. So anything you feel like you want to ask the HFTO technical committee, please come to Nashville or get us some questions, and we'll try to answer them during the committee meeting. And we're looking forward to seeing everyone there. Please, guys, bring your family and friends. Come to Nashville. You're really going to like it. Thank you.
Thank you, Danny and Kelly, and thank all of you for participating in today's webinar. I think it was really beneficial for all of us. So with that, we're going to conclude. But as I had said at the beginning of the webinar, the recording of today's webinar will be available on the NTPEP YouTube channel, probably by the end of today or so. So please reach out if you do have any additional questions. But thanks again, and have a great day, everyone. Take care.